All right. Sorry to everyone that was trying to watch my stream. I was having some major technical difficulties. I really apologize for that. For some context, if any of you have been following me on YouTube or TikTok or any of these social media platforms, I recently reset my machine because I was having some crazy issues with my machine, my computer, and so I wanted to do a full factory reset to make sure everything was back to normal. And because of this, there have been some hiccups here and there, me trying to get some of my settings back to make sure we're on a strong foundation for the streams coming up. So with that being said, I'm really happy to be back. I think everything's good now. If anything sounds weird or feels weird, please just let me know on the chat. That way I can try and address it, and that way I can make sure that everyone has like a good streaming quality and a good viewing, if you will. So today we're going to do more LeetCoding coding. For anyone that's new to the channel, we are currently at 156 questions solved on YouTube. And let me give you a little bit, not on YouTube, but on LeetCode. LeetCode. I have been having issues saying LeetCode recently, but let me give you a little bit of context. If you're looking for a way to break into software engineering, if you're looking for a way to get better with problem solving, LeetCode is the way to do it. And before I dive into this, let me show you what I'm up to over here on YouTube. So if we come over here, there's a playlist that I have, and this is really where it all started. So a little over 3 weeks ago, tomorrow is actually going to be the first 4 weeks, so a whole month that we've been doing this. You can go all the way back here and look at the first video in this easy collection playlist I have, and you can watch every single video for every single day because I do these daily. And on each video, for example, if I click on this one, the first one, you're going to see that there's chapters for easy navigation and links to all the different LeetCode questions. On top of this, I even have a website that I created called raphaelslist.com because my name is Raphael. You can visit it on raphaelslist.com, and here you can filter different questions by topic, and you can also expand this easy details pane here to look at all the questions that I've deemed top quality questions based on the questions that we've done so far. So I'm hoping this helps you on your journey. Please let me know your progress, and let's just all become, it's a big community that's just trying to get better, right? Because that's really what it's all about. Software engineering is very collaborative, so I'm looking to try and help people become better, including myself. So that's pretty neat. All right, so yesterday we left off. Is this page 1? I think because we're definitely on page 2. These past 2 days have been so-so in terms of questions. So we were doing this one yesterday, but I want to just go to the next one. So this next one is FizzBuzz, which is a super popular question. It's a question that interviewers love to throw at you. So let's just go ahead and think about it and try to see how we can solve this, right? So the instructions are pretty clear. It says, given an integer n, return a string array answer, one indexed, where answer I equals FizzBuzz if I is divisible by 3, answer I is Fizz if I is divisible by 3 and 5, or Buzz if it's just 5, else we can just do I. So let's think about how we can do this. I as a string, so I wonder if we can just do, right, like let's imagine we have our result, or it wants us to output this as a result, right? So let's say we have const result. This is going to equal just like an empty array to start off. And then what we can do, I think I had this set to 2 tabs. I'm going to make this 4 spaces rather. That way I don't have to deal with that weird tabbing thing there. What we can do is we can essentially just create a new string here. Let's say, I don't know, what would I call one of this? Like, I guess just str, maybe. And here we can say if, let's see, if it's 3, if it's 5, if it's 3 and 5, it'll just be FizzBuzz. I think we can just start off with an empty string, and we can say if n modulo 3, we actually should go for let I equals 1, I less than or equal to n, I plus plus. I'm going to go ahead and move this inside of this for loop because we're always going to want to generate this new string. And here we can say if I modulo 3 equals 0, we can say str plus or equals fizz. If I modulo 5 is equal to 0, str plus or equals buzz. And let's see, and if not, so if it's not this or this, so I want to consider these two, but then at the end, what is it that we want to put? Can we put string? Do we just check to see if it's empty? And if it's empty, maybe here we can do result.push string or string of I. Now I think, if I remember correctly, does an empty string resolve to falsy? If I do like this, for example, okay, it does resolve to falsy. So what I did here was I just want to make sure that an empty string is a falsy value. And we can use, I don't know what this is called. I don't think it's like short circuit evaluation. It's just essentially saying, like, if the left hand is false, choose the right side. If the left hand is true, I'll just pick this first one. So at the end, right, like if it's 3, it'll just be fizz, which in this case, string will be truthy, so I'll pick string. If it's 5, it'll be buzz, which in this case, string will be truthy, so I'll pick string. If it's 3 and 5, it'll be FizzBuzz, truthy. Else, if at the end it wasn't 3 or 5, then string will be false, and I'll just push string of I, because it wants I as a string. And here we should just be able to return result. So let's see what this gives us. Let me disconnect my keyboard here. All right, there you go. Gotta disconnect my keyboard for maximum mobility. So I think this is good. Let's try some other test cases. 1, 2, fizz, 4, buzz. 1, 2, fizz, 4, buzz, fizz. That all looks good to me. Submit it. 71.64. Sweet. So again, like this, I like this a lot. And you know, in the beginning, the first time I tried to do this question, what I would normally do is maybe do like a switch statement or like an if statement, and do like, oh, if I is divisible by 3 and 5, do this. Else if it's just divisible by 3, do this. Else if 5, do this. Else just push. But in this case, we can just very easily like introduce different, I guess, divisions into here and just concatenate something new to our string here. And this sort of takes care of both fizz and buzz and then empty strings by using this or conditional right here. So I think it's like pretty nice, elegant way of doing it. If we think about the time complexity, the time will be linear because we're definitely going to need to go from 1 all the way through n. So depending on this number, this for loop will grow linearly. And our space complexity will also be linear. We're going to have to create a new array that is at least n indices long. So linear on both time and space. Pretty straightforward question, but it's one of those that is, it could be tricky, and I almost think it's like the hello world of data structures and algorithms. Probably interviewers are looking to see if you can make this sort of elegantly, and I think this is a pretty elegant way of doing it. So I think that gives us a nice good start. Let's go to Pascal's Triangle. Okay, so given an integer nums rows, return the first nums rows of Pascal's Triangle. And it's saying it just wants this last one here. Oh, it wants every single one. Okay. So I feel like we should draw this out perhaps. Or when I look at something like this, I'm not like, kind of looks like a tree, but it like looks like a tree, but it also really doesn't. I don't know. But I almost think this is like recursive in nature, right? Because to get this 4, we have to figure out these two up here, right? And then to get like this one, we figure out this 2. To get this one, or actually like these are just like our base cases, right? That's almost like what I'm thinking. But instead of base cases, let me see if there's like another way that we can think about this. So what is one similarity that we have here? Both, like all the ones on the left and all the ones on the right, it always is going to be 1. And we always know that we're going to have at least 1 and then 1, 1. And then this is where things are going to get interesting, right? So let's see if we can figure it out. Let's imagine that like that's the top, right? And that's the bottom. And then let's for the third row just add 1, 1 because we're going to need to do that. So how is it that we figure out the middle number here? Can we look at, let's see, 2, we just have to go to the 2 on top. To get this one, we have 1, 2, 1 in our previous one. I wonder if we can just do 1 plus 1. What if we had a pointer to like the previous one and we iterated over this one? we iterate over the previous one and we say, okay, 1 plus 1, that's 2. So we add that there. And then we go I plus plus, we get to this one. And now we cannot get to the next one, right? So that's where this one stops. And then for the next one, let's again say we have 1 and 1. And now we start the loop over again. We start at the previous one, so we look at I equals 0. We're essentially going to go from I to length minus 1. So we can see 1 plus 2 here, that's 3. And then 2 plus 1, that's another 3. And we can just sort of keep going that way. So I think that's what it is. And how is it that we... Now I guess I want to know, like, when do we stop? Maybe we just always start at... This would be nice though, because like it's always going to be the same. Let me see. It's always going to be the same. 1, 2, 3, 4, 5. So I know I know at the end we're going to have some result, right? Obviously, we're going to have some result where each row 0, 1, 2, 3, 4. So rows is eventually going to become size 5. So if I created a new array like const rows equals this. Let's think about this. I think we don't even have to consider. I think I'm okay with just saying let's make this 1 and 1, 1 by default. Num rows 5, num rows 1. Oh, but then it wants the output 1. So it'd be nice if we can, because if I'm given 1 and I go to I minus 1, I'm not going to be able to do that, right? How would I get the next one? Unless do I just consider this to be 0, like 1 plus 1? Or if rows is 1, we can say something like if num rows is equal to 1, we can just return 1. If num rows is equal to 2, we can return 1 and 1, 1, right? And now what if we craft rows now? We say rows, and here we'll put 1 and we'll put 1, 1, because now it's going to be some number of rows that's greater than 2. It's going to be at least 3. So that means we'll be able to get to this piece now. And what can we say? We can say, let's see, num rows. How many more rows do we have to figure out now? We know we at least have 1, 2, so we need to do 3, 4, 5. So here we can say const rows, let rows remaining equal num rows minus 2. And say while rows remaining is greater than 0, what is it that we want to do? We can say const new row is equal to 1 and 1, right? 1 and 1 because we always know that the beginning and the end are going to have a 1. And now we know that to figure this 2 out, we can essentially just, what we can do is we can say for let I equals 0, I less than, let's see, we need to get the current rows. So like the previous row, let's say const new row, let's get the previous row here. Const previous row is rows at rows dot length minus 1. Here we can say I less than previous row dot length minus 1, I plus plus. And here we can say, oh wait, we shouldn't do 1 and 1, right? We should only put 1, and I can say new row dot push. We want to do previous row of I plus previous row of I plus 1. Let me actually put row here. New row push previous row I plus previous row, plus previous row I plus 1. And then at the end, we should just do new row dot push 1 and rows dot push new row. And then we'll have rows remaining minus equals 1. And then we can return rows. Let's see what this does here. Although this feels like a very, very like, 1, 2, 1. This really feels like it can be a nice recursive algorithm. If num rows. Okay. Okay, that looks good. Let's run all the test cases. Let me also check something on, my stream just to make sure we're all good. Just because I've had like some recent hiccups, I really just want to make sure everything's sounding fine. If I go here, let's listen to this real quick for 1 second. Been live. If I go here, okay, cool. That all sounds good. All right, sweet. So that looks good for, was it both test cases that ran fine? One, okay, let's submit this. Okay, 36.37. I'm gonna wait a couple seconds and run it again. I'm okay with this. Let's analyze the time complexity of this. Okay, 61.61. So here, like, how many times is rows remaining going to run? Rows remaining is going to run O of n minus 2 times. Really, it's just O of n times. And then this will also be O of n. So right now, this is an n squared algorithm, right? Because it's, like we just saw, this is n minus 2 times, but that's essentially, we dropped the constant 2. For each one of these, we're going to be going through the previous rows dot length, which is always, it converges towards 1 or converges towards at least 3, but it's not really going to be like, is it constant though? Because maybe Pascal's triangle is always the same size. Number of rows is 30. So I wonder if this is actually, I don't know if this is constant. I'm very curious about that. So that's what I would say for time and space complexity, or time complexity. It might be linear, because maybe this is constant, because these rows will always be the same. It doesn't matter the amount we have, they'll always have like the same distance. It's going to incur some performance, but perhaps it's just constant. And then let's see, for space, we're creating rows here. So that's just linear, right? Like however large num rows is, it will grow linearly in regards to that. But I kind of want to turn this into, see if we can come up with a recursive algorithm, because these are our two base cases, right? Now, what do we do? What do we do if it's like 3 though? Do I start from, like, do I generate the previous one and then also just do this loop? I wonder if that's, I mean, we can try that. Let's see. Num rows, and then we have here rows. We'll make this an empty array. Here we know that if, so let's say if num rows is equal to 1, again, we're going to return 1. If num rows is equal to 2, we're going to return 1, 1. And now if we're at a 3, I want to return, do I want to return, if I go to generate n minus 2, that's just going to give me a 2. Like, am I ever going to make it to the 1? And if I go to a 2, maybe it should just be 1. Maybe it should just be this, and I can say const previous row equals generate num rows minus 1, right? Num rows minus 1, and we'll pass in rows. This will return the previous row, and then maybe to rows dot push previous row. What if I passed in 1 though? What if I pass in 1 and make this, and we say previous row, if num rows is 0, we return an empty array. So if it's 1, I pass in num's row, I'll return an empty array. And then to this one, what do we push? If I have a previous one, 1 plus 1. If I don't have a previous one, the reason I'm doing this is because, like, I can't make both of my best cases this, because if I start at 3 and I do minus 1, it's going to get to 2, but it's just going to immediately return this. It's never going to get a chance to go to this previous one. So how do I generate 1, 1 from, oh, I think I know. And you know what? I think we can make this, if it's 1, we just return this. Right? If it's 1, we just return this. else anything else, we, let's see, we get the previous row. So if I do 2, I get the previous row. Should I push? I should say maybe like rows.push previous row. Maybe here we can say const new row. Yeah, maybe here we can say const new row equals 1 for let I, and I think we can just do the same thing we did here. For let I equals this, I less than previous row dot length. And here we say new row dot push, where we can say new row dot push 1. New row dot push 1. And then can we just return rows here? I just deleted a lot, but I want to see how this might work. Well, let me just run this and see what happens, right? Is there any harm in running it? 1, 2, 3, 4. Okay, so we definitely didn't get what we wanted here. But I feel like we're onto something though, right? Because if we get a 2, so we get a 2, what happens if I get a 3? If I get a 3, I go to 2. I come over here, I do 2. I go to the previous one, return 1. So now I'm at the 2. Rows is this. Okay, maybe I should always make this that, and then we can just say return rows. If it's 2, return rows, rows.push. Okay, no, maybe here we can say I'll create a new row, previous.length, try to push, and then new row. So let's try this one out. 1 and 1, okay. Let's again consider 2. So if I'm given 2, I get my previous row, I return rows, but I'm not actually adding that. Oh no, that's fine. Return rows. Then I'm here, I say new row for let I less than previous row, no, new row dot push. Oh, and then rows dot push new row, return rows. Let's see what this does. Okay, I feel like we get a little bit closer every single time, but not quite. If I have a 3, I call 2, call 1, return rows, rows.push, return rows, previous rows is going to be that one. New row is 1. Previous row, oh, previous row is not going to be, this is going to be all my rows. Maybe here this should be rows. I return rows and I come over here. Maybe previous row should equal rows.rows.length minus 1. New row.push, rows.push, new row. Let's try this one out. Sort of going like trying a lot of different things out. Okay, const rows. It doesn't like this one. Let me say like new rows. It's not like my favorite thing. New row.push, rows.push, new row. Now I have a lot of like rows scattered everywhere. If it doesn't work out for us here. Oh, wow. Okay, cool. Does this work if I submit this one? 88.56. That ran way faster. Now, is this because I have one row? I guess this one, like, what's the time? Like, I'm only, oh, wow, the recursion's taking care of it for us, right? Well, this is going to happen row times n, I guess, row by n. For every row, we're going to have a previous row operation, and the space complexity will just be the internal stack space. So yeah, this is a really nice question to practice for recursion. Let me see if I submit it one more time if we're going to get that high of a percentage. Oh, so it looks like this is, without a doubt, the way to solve this question. So if num rows is equal to 1, we're just going to return the rows that we already have, right? Else, what is it that we want to do? What is this one? What should I call this? Generate new rows? I almost feel like this should be maybe like current rows. Maybe new rows can be current rows. Previous row is current rows, I thought 1, and then we create our new row here. We go to the previous row, rows.push new row, and we return rows. So when we get here, that's what our current rows are. Yeah, nice question. Very, very nice question. So it's cool. We did sort of like an iterative way and a recursive way. So I think that hopefully that provides some good value for everyone watching, and I really hope you all learned a little bit from that. Again, I know I tend to probably go through these things really quickly, but I know I've said it all the time, but you know, my intent is really just to sort of give you like a raw look into how I might try and solve this question. Not necessarily to teach, but I hope that through you, through you seeing me and hearing me make these mistakes and like how we just, made some mistakes there, I hope that you all take something from that. So that's pretty neat. Let's get to the next one. So far, it's being good today. Like, I like these questions. Find the words that can be formed by the characters. You're given an array of string words and a string cars. A string is good if it can be formed by characters from cars. Return the sum of lengths of all good words. So each character can only be used once. Can I create cat? Yeah, I can create cat because there's at least one of each one of those. Can I create BT? Yeah, I can. Okay, so I think at every point. Now I don't want to create like a copy of this string or anything. Let me see. The strings that can be formed are cat and hat. Like for each one of these, if all the letters are represented in here, but I also need to keep track of their frequencies, but I also don't want to lose out. Not like lose out, but I think I know what we can do, but let me see something. This is cars.length consists of lowercase English letters. Okay, let's do this. We're going to create a frequency map. We're going to create a frequency of a new array of size 26. We're going to fill that up with 0. Very similar thing we always do. We're going to go through every single character in cars for const c of cars. We're going to get the code. We're going to get the index, which will be c.carcode at 0 minus 97. This is just normalizing it so that lowercase a bounds to index 0. And then inside of frequency here, we'll just say plus or equals 1. Now what we can do, what we can do, I would like to make a function for this. So I can say const is good character, is good word. This is going to take a word. It'll take a word and it'll take I think I want it to take a word and it'll also take a frequency map. So what I'm thinking about doing here is for that word, so I'll say for const c of word, we'll get the code, we'll get the index, c.car code at 0 minus 97, and we'll say if, let's see, so I want to check, so if there's one available, okay. So I can say if it's already 0, right? If at any point it's 0, or if it's less than 0. So I can say if frequency map at index is less than 0, then we return, or I can say less than or equal to 0. We return false, else frequency map, and we can actually do frequency map index minus minus, because all this does is it first checks. It's like a postfix operator, so it'll check this first against less than or equal to 0, and then it'll just decrement it, which is what we want, right? Else, what we can return here, well, maybe I'll just return true here, right? And now all we need to do, we can say let, it wants the length. Okay, so let's say let length equals 0 for const word of words. We can say if is good word, and here I'm going to pass a clone, a copy of frequency. Here I can say length plus or equals word dot length, return length. This is, let's see, cool question. 6 and 6. Let's run this again. Going a little bit slow. 610, 610. I don't know if that was just like LeetCode acting up or 87.09. So I just realized that this pattern here is very common. Like creating a frequency map or like a clone of a frequency map for some iteration. Like for every iteration, you need to consider a new frequency to see if you can create something based off of that. And that's exactly what we're doing here, right? We're constantly passing in this new frequency, and that's what we're using every single time. So let's try to consider the time and space complexity here. This is going to be a constant time operation because we're just doing it once, and it's a constantly filled array. And this is also going to be, oh no, wait, this is C of cars. And we know that cars, yeah, it's going to be from 1 to 100. So this will be O of, I guess, N. This will be O of M, where M is the length of cars. Here, this will be low of N, right? But like for every word, how long does is good word take? Like good word can, worst case, go through every single character, right? So this is this is M by N, where M is every single word and N is every single character in that word. So I think our bottleneck really becomes this down here, which is M by N. And then our space complexity is constant because we always create a new array. Even though we're always creating a new array, it's always the same size. So it's just constant space. So let's submit this again and let's see what we get here. 93.92. So yeah, really happy with these numbers. I think this is cool. Something that I've sort of like gotten better at, I think, and I hope this is something that you all see, is creating just functions to help me create what I hope is cleaner looking code. I don't feel like I would have done so many of these functions earlier on in this whole like journey. So I think it's pretty cool that just by practicing it and reading other solutions and sort of seeing what other people are doing, it's helped me get better. So I hope that by you all watching me sort of do something similar. Yeah, let me do some that I haven't done yet, because all the questions we've done so far have been really nice. Like I'm going to add all these to my list, and I'll also add all of them to not only this list on LeetCode, I will add all of them to Raphael's list. That way you guys can see them and it'll be easier for you guys to find them. All right, count square sum triples. A square triple ABC is a triple where A, B, and C are integers. Given an integer n, return the number of square triples such that A... Oh, that was a good yawn. Given an integer n, return the number of square triples such that 1 is less than or equal to A, B, C is less than or equal to n. Square triples are 3, 4, 5, and 4, 3, 5, okay? The square triples are 3, 4, 5, 4, 3, 5, 6, 8, 10, and 8, 6, 10. A, B, and C are integers. Oh, A squared plus B squared equals C squared. Given an integer n, return the number of square triples. I mean, one thing I think of is like coming up with the permutations of all the numbers. But this is... seems like overkill to do that. And especially seems like overkill for an easy question. What if we, you know what we can do? I'm pretty sure Can we? Yeah, we can brute force this. We can brute force this. This reminds me of another one that was very similar. But I mean, I feel like that's the way that I would try to do it, to brute force it. So it would be something like, for let I equals 0, I less than, is it n inclusive, like 5? Okay, up to 5. Okay, yeah. I less than or equal to n, I plus for let, and can you use the same number? They all have to be different. 8, 6, okay, yeah. For let j equals I plus 1, j less than or equal to n, j plus plus. And then similarly here for let, and you know what? I should make this ABC because it'll just be way easier to like reason about. B equals a plus 1, b less than or equal to n, b plus plus. For let c equals b plus 1, c less than or equal to n, c plus plus. I think here it's just that. So if, let me see, const left equals math.pow of a squared plus math.pow of b squared, const right equals math.pow of c squared. If left equals right, can we just push our result? Const triples is an array. Can we just do triples dot push a, b, and c? Return triples. Is that something that we can do? Nan. So const left. Oh, wait a second. It shouldn't. Oh, no, yeah. This is going to be to 1, though. Although that, I feel like that shouldn't matter, but a plus 1, c equals b plus 1. Number of square triples such that 1 is less than or equal to a, b, c is less than or equal to n. This returns nan. Return triples, count triples. I feel like I'm missing something here. So for let a equals to 1, a less than or equal to n, a plus plus. For let b equals a plus 1, b less than or equal to n, b plus plus. For let c equals b plus 1, c less than or equal to n, c plus plus. Const left equals math.pow of a squared plus math.pow of b to the power of 2. Const right equals math.pow of c to the power of 2. If left equals right. Why is it not even... Oh, wait. Oh, they want a number. Okay. Triples equals 0. Triples plus or equals 1. See this one? Classic mistake. 1 and 2. Okay, so that's already bad. 3, 4, 5, and 4, 3, 5. So you know what? These probably don't all. These probably all shouldn't start at b plus 1 or whatever, right? Because here this is 4, 3, 5. Let me just remove this here. Okay, 5, 2, 2, and then for our 10, 2 and 4. Now, is it a mathy solution? I mean, I'm okay with this. I mean, this is definitely the brute force way of doing it. 100% memory usage though, so that's nice. I mean, that has to count for something, right? It's like locked in 17.57. Can we see related topics since we solved it? Okay, math and enumeration. If this is just like a math question. Oh, it loves that number. Okay, let's see discussion. First, we mark all I in the squares array. We then loop I and j and check if the sum of their squares is in the squares array. Note that the limit of the inner loop is to make sure that, as another optimization, we run the inner loop from I, not from 0, and we add 2 when we find a matching triplet. right. You can just use n instead of 250. Squares is n times n plus 1 for int I. Okay, it's just 1, so we can go to the end. Okay. Int I is 1, I less than, squares I of I equals true. Okay, so they're just taking the squares. J less than n times n plus j, res plus or equals squares. I mean, this is like a weird answer. Let me see what else we got here. Python simple solution. Res plus or equals 2. O of n squared. C plus or equals 2, return C. The square root is I. Okay, I plus j. Int r is the square root of sq. Okay. If r times r equals square root, and r is less than or equal to n, c plus or equals 2. Should the time be O of n squared? Should be, considering that square root works in log n time. Brute force versus logarithmic. Turn res. I don't like math that much, so let's move on to something that might be more valuable. I think that's a cool question, but I'm not sure if it's really going to help us out here. Count square sum triples. Okay, goat Latin. But I'm happy that we solved it. I mean, we did it, right? This looks fun. Okay, you're given a string sentence that consists of words separated by spaces. Okay, each word consists of lowercase and uppercase letters only. We would like to convert the sentence to goat Latin. The rules of goat Latin are as follows. If a word begins with a vowel A, I, O, U, append ma to the end of the word. For example, apple-ma. If a word begins with a consonant, remove the first letter and append it to the end. Then add ma. So otgma. Add one letter A to the end of each word per its word index in the sentence. The first word gets A added to the end, the second word gets AA added to the end, and so on. Now, I hope they don't want me to do this in place, because there's certainly a way that we can make this easy, and there's a way that we can make it real hard. Let's see. Okay, so apple, we just append them all. Okay, and then we just add one letter. I think what we can do here, let's say const goats, that's just going to be the array that we output. Let's start going through each, like for I equals 0, I less than sentence. Actually, we need to split this, right? So let's do, yeah, I guess we can do for let I equals 0, I less than sentence dot split at space dot length I plus plus. Okay, so const word. Oh yeah, let's just say const split equals sentence dot split. That way it's just easier to deal with this. And now we can say for const, no, it should still be for let I equals 0, I less than split dot length. To get the word, we're going to be const word equals split at 0. Now we got to figure out all these different things here, right? So let's create like a const vowel regex. If a word begins with A, E, I, O, U, I need to figure out like regex begin. Oh wow, regex begins with. There's like an anchor, right? The first token. Let's see. Looking inside. Strings ending with multiple line breaks. No. Anchors, beginning of text, and the other one at the end. Okay. So if we do regexer, this is a great website. So if I have, how would I say, I think we can just do this. So if if I do oh wait, oh, is it not working because why is it only doing once? Is this considered a whole? Do we need? I think that might work. If I do vowel regex equals new regular expression, we do this A, E, I, O, U. Okay. So if vowel regex dot test this word, if that's true, then we know that this rule applies, right? Else we're gonna get to this one. But like every single time though, we're always gonna do this thing down here with the A's. So if a word begins, then we append ma to the end of the word. So I can say const new word equals word plus ma. Or let's do this. Let's do let new word. We can say new word equals word plus ma. Right, word plus ma. Else remove the first letter and append it to the end. Then add ma. Okay. I think what I can do is I can get const first letter equals word at 0. Const remainder equals word dot slice starting at 1. Remove the first letter, append it to the end. New word equals, let's see, remainder plus first letter plus ma. Right? Add one letter to the end of each word per its index in the sentence. New word equals that, and also ma. And then what we can say for let I equals, let's see, if we're currently on 0, I want to go to I plus 1. So for let I equals 0, or maybe not this, we should say like for let, what I want to do is now for every single, like if we're on 1, we're going to add 1. So really, I want to add I plus 1 A's to this. So I can say for let's just say j equals 0, j less than I plus 1, j plus plus, new word plus or equals A. So it'll be 0, j less than I plus 1, which is 1. The first time we'll just add 1A, and then we should just be able to return, let me see, I speak goat Latin, okay. And it also, it even wants me to do, let's just say, oh no, wait, we have goats up there, right? Let's just say goats dot push new word, and then we can return goats dot join. I think we need a space in there if I'm not mistaken. Let's see what this does. I'm okay. That obviously, oh wait, word equals split at I. Okay, so that's already one thing that we messed up on. Okay, that looks good. Let's get to the next one. Some crazy stuff here. I don't know if that's right. Over Hetsma Azialala. I think that might be right. I don't know what. Oh, okay, it cut off here because the diff. Okay, is there? So if we submit this, each word consists of lowercase and uppercase letters only. Where did we go wrong? Oh, I should make this. Should this be case insensitive? Nice, okay. Man, regex works really nicely for this. Now, I'm okay, you can see that this is not a great question. A lot of people don't like it. I think that I think it's just one of those questions you just got to do exactly what it tells you to do. That's what I did. I mean, we created goats. We have our sentence split here. We created this vowel regex so we can do the thing it's asking for with the A, E, I, or U's. And then we just start to look at each one. If it passes the vowel one, we just do them all thing. Else, we get the first letter, we get the remainder, we do that whole concatenation. Then we get our new word. We add however many A's we need to add. But you know what might be even better? Instead of having to do this, we could do let added A equals A. Yeah, and I think what we should do here is we can say new word plus or equals to added A, and then added A plus or equals A. Now, is that going to make it faster? Really? I don't know. I don't know, actually. Like, under the covers, under the hood, how does it work? Like, if I'm concatenating to a new string, will it create a new one and then append it at the end or push it? Or is it just like a constant time? Whoa. Okay. I mean, this is, wow, 100%, man. Just from doing this down here. Why does that string concatenation? JavaScript string concatenation time complexity. What is the time complexity for string concatenation? Any big O performance for any operations? That's it, I would like to guess. Most likely to be O of n. Okay. Array dot push dot join. Many programming languages, Eastern concatenation loops discourage dedicated classes to do that. Modern JavaScript engines will internally optimize your first approach to behave like the second, so there's no need to do that yourself. Interesting. Okay. So maybe it does, maybe like it would make sense to just make these an array. Like instead of dealing with strings, we just make all these arrays and then always use join at the end for each one of these. Like we join the new word every time right before we push it. But 100%, I mean, hey, I'm really happy about that. I'm really happy about that on a question that has this sort of like to dislike ratio. So let's keep going. Number of students unable to eat lunch. That sucks. Can't eat lunch? School cafeteria offers circular and square sandwiches at lunch break. Referred to by numbers 0 and 1 respectively, all students stand in a queue. Each student either prefers square or circular sandwiches. The number of sandwiches in the cafeteria is equal to the number of students. The sandwiches are placed in a stack. Hint, hint. At each step, if the student at the front of the queue prefers a sandwich on the top of the stack, they will take it and leave the queue. Otherwise, they will leave it and go to the queue's end. This continues until none of the queue students want to take the top sandwich and thus are unable to eat. Given two integer arrays, students and sandwiches, where sandwich is I, type of the ith sandwich. Okay, that's the thing here. Students 1100, sandwiches 01. So from front student leaves the top sandwich and returns to the end of the line, making it 1001. Okay. Front student leaves the top sandwich and returns to the end. Front student takes front, hence all students are unable to eat. Oh, okay. So none of the queue students want to take the top sandwich and thus are unable to eat. So we want to go until none of the students are unable to take the top. So 1 takes 1, okay, and he leaves. But sandwich is also taken, and then 1 is not taken, so it goes to the back. 1 is taken, it goes to the back. And this is return the number of students that are unable to eat. Now, when do we, I feel like, do I have to keep track of like when we start? Like who is the person in front? And leave the queue. Otherwise, they will leave it and go to the queue's end. This will continue until none of the queue students want to take the top sandwich and are thus unable to eat. I feel like there's a lot of different ways to solve this. It's also like at any given point, I want to check to see, like, what if I had a frequency, like I had the amount of sandwiches left. I have 2 0 sandwiches and 1 0 sandwiches. So 1, no, doesn't take it, but 1 doesn't take that one. 0 does take that one. No more 0 sandwiches. 0 takes, let's see, 0 takes that one. No more 0. 0 can't take 1. But now 1 comes back. Okay. Takes that one. This one, yeah, what if we did that, right? We have students and we have sandwiches. Like here we have 3 1s and 3 0s. So 1 is 3, 0 is 3. So 1 takes the 1 sandwich, so both of these leave, right? And now we have 2 1 sandwiches. 1 does not take the 0 sandwich, so this one goes to the end. 1 does not take the 0 sandwich, so this one goes to the end. 0 does take 0 sandwich, so there's 2 0 sandwiches left. And same for here, so we can effectively remove both of these, making it so that there's 1 0 sandwich. 1 does not take that one, so it goes to the end. And this continues, right? Like no one's gonna take the top one anymore, even though there's 0 sandwiches. Oh, okay. So at this point, there's no more 0 students. So if at any point, what if it's something like, we can say like do the algorithm, which is the looping thing. If there is no student to sandwich, return. If there is no sandwich to students, return. So let's say we had students frequency, and let's say we also had const sandwich frequency. Okay. Now are these always going to be the same size? They're not going to be the same size. So let's do this. We have both of these. We can say get frequency. We're going to be given some array. We'll say for const val of r. We'll just say that's the array, and then here we're given, and maybe, yes, the thing I want to go through and the thing I need to create, right? So here, let's say const frequency equals this, right? We can say for const val of r, we'll say frequency of val equals frequency of val plus 1 or 1, return frequency. Let's fix this up here. I keep going into insert mode. How do I take that off? Should just be, oh, is it Shift FN? That's not good. I'm not good with shift mode. Anyway, we'll try to figure it out. Okay, so now both of these, I can just make this one to get frequency of sandwiches. This one's get frequency of students. Now, we really just want to do like, and leaves the line making students and sandwiches. All students are able to eat. I can say while students dot length greater than 0 and sandwiches dot length greater than 0. If we ever make it out of here, we're going to return true, right? While students, because if both of these fail, that means they're both empty. So we know that everyone can eat. But what can we do in the meantime? So we got to get the one from the top on each one. Now this is going to be a little bit annoying, but let's see. So we just want to match a student to a sandwich. Right, so if students of 0 equals sandwiches at 0, then we can just essentially remove both of these. Now if I do unshift, does that just give me the element that adds or adds one or more? No, it's shift. I want to look at shift. Because does that return from the removed elements? Okay. Changes the length of the array. So here we can say if students of 0 equals sandwiches of 0, I can say students.shift sandwiches.shift. We should also do sandwich frequency of sandwiches at I minus equal 1, and student frequency of sandwiches of I minus equal to 1. No, this should be not of sandwiches, this should be of students. All right, so they both had one, and now they can eat it. Right, so we remove both of them. Now I said up here, if there's no student, let's say this is not true, we should also check to see if it will ever be true. Like if it's a 1 and a 0, right? So like if there's a student 1 trying to get a sandwich 0, or if there's a student 0 paired to a 1, we need to make sure that either of the cases is true. So now we're gonna kind of do the opposite. I can say if sandwich frequency, all right, maybe I'll go in here, else they don't match, so now we gotta check to see for that student, is there a sandwich left? So if sandwich frequency, right, this is gonna be a little stranger. If sandwich frequency, I shouldn't have done this, right? Oh man, how the heck do I take off? I really need to take off this Control Shift Insert. Oh man, this is not good. Okay, if sandwich frequency, okay. If sandwich frequency of students of I equals 0, or student frequency of sandwiches of I equals 0, return false. So what is it that I'm trying to check here? So sandwich frequency, let me actually make this like this. Sandwich frequency holds all the different sandwich types, right? So like if students 1, if inside of sandwich frequency there's not a sandwich of 1 anymore, that means that this student will never be able to get one. So we'll just return false, right? And students, if there's like one student, and in sandwiches there's never a 1, then we don't do anything. All right, so what have we saw here? Here, it's only if they're the same. Else, if they're not the same, we first want to check this, but we can leave the sandwiches as they are, and we'll do the thing where we pop the student. So we'll say const shifted students equal students dot shift, and then we'll say students dot push. Maybe here I can just say students dot push students dot shift. So I think let's just run this. Sandwich frequency students of, oh, why was it that I was doing that? If students at 0, else if sandwich frequency of students at 0. Yeah, this should always be 0. Oh man. Trying to figure out creative ways of managing that insert. Return false. Doesn't like something in here. Oh, yeah. Really? Okay, this is also 0. Let me see how to like remove the insert. Get off insert mode. This is a razor widow or something like that. That's my keyboard. Insert key doesn't toggle. How do I turn off insert mode? Turn off insert mode keyboard razor. Press the insert key to toggle overtype off. Is it just that? Like if I just do insert mode. Oh my god, it's just that. I don't even need to do the function key. One and 0. Oh wait, but I'm not even returning a number. That's grand. Continue. Sandwiches are placed in the stack. Queues end. Given 2 integers, 0, 1, 0. Oh wait, front student takes the top sandwich and returns to the end of the line, making students. Okay. It continues until none of the queue students want to take the top sandwich. And then we should just return how many students are unable to eat. Okay, so here we should say students dot length, and here we should say 0. Let's try this out. 0 and 0. Run this. Ooh, I sense a students.push, students.length, students.length, time limit exceeded for this one, 111. At any given point, let's see, I want to go over this real quick. We have this one and we have sandwiches. All right, so students.length and sandwiches length are both greater. So if students 0 equals sandwiches of 0, we shift this one and we shift this one. We also remove, yeah, let's also make sure we're getting that map in there. So let's say this is sandwich. So I'm gonna put the sandwich one up here. So what we have 3 1s and 3 0s. And then we'll put students. All right, this is gonna be my students. 3 students and 2 sandwiches. 3 students and, okay, 2 students. Okay, cool. All right, so we remove 1 from each since we can do it. All right, so we remove sandwich frequency, sandwiches of 0. You know what we should do? We should say const removed. We should say const student. And here we should say const sandwich. And this is the one that we remove, right? So no, sandwich frequency is sandwich and student frequency. Let's do this again. So let's put a 1 in here. Let's put a 1 in here. Okay, both are the same. So we remove from both. They are both 1 and 1. So in the sandwich frequency, I should remove. Yeah, why did I keep messing that up? No, this is sandwich and this is student. Student frequency, remove. Now there's only 2 students. There's only 2 1 sandwiches. Great. Gets to the next one. Both of these are not both the same, right? So we come down here. If sandwich frequency of students of 0, so students of 0 is 1, but there are 2 1 sandwiches left, so that's fine. Student frequency of sandwiches at 0. Sandwiches of 0 is 1, and there's 2 students, so there are students able to eat that sandwich. return, none of these are equal to 0, so that's fine. So we say students.push students.shift. So students.shift, remove that, and now we push this next one. This is not the same. So we, again, do the same thing, right? We remove this one, push that one. These are now both the same. So we do this one, we do this one. We have two 0 students left and 1 0 sandwich left. Sweet. We do the same thing. Come down here. These are the same. These are the same. Students, we have no more 0 students. We have 1 more 0 sandwich. Now we get here. These are not both the same. Okay. If sandwich frequency. So what's students at 0? Students at 0 is 1. We do have sandwiches available. Sandwiches of 0. Let's see. Sandwiches of 0 is 0. And the student frequency of 0 is 0. So we should have returned students.length there. Unless what happened was, is this not, that was for the, that's interesting. So why wouldn't that student frequency of sandwiches 0? Oh, wait a second. Shift, okay. Students.push. Move the students, move the students. That's fine. We just we shifted both of them out. I feel like this part should break here. Student frequency. Right? Because we're just getting our frequency like this. Frequency val for val of array, which is student. Frequency of 1 is frequency of 1 or frequency of 0. Sandwiches, students, sandwich frequency, student frequency. That's the sandwich that we removed. If I do this again, this is gonna break. Yeah, it doesn't like this here. Let's run this again. Oh, 0303. Let's run it. So what if that works though? Ah, man, close. Maybe we're close. It's time limit exceeded, I'm guessing. Expected output 4, expected 3. Yeah, so it took long and we got the wrong answer. So I'm good with that. I think since we're just over the hour now, I know we left it so close to the end, but again, I like to try and keep these short just for people that are watching. But I think that we solved like a good amount. 1, 2, 3, 4, 5. Yeah, we did 5 of them, which 5 is always like a good number for me for easy streams, especially at an hour long. I think that there's a lot of like value in there, and that's exciting. So thanks again to everyone that watched. I'm gonna go ahead and upload these. If you don't already know of my website, we have rafaelslist.com. This website's pretty cool. I came up with it for viewers of this channel. So on each one of these different questions, you get linked to the LeetCode question. And the most important thing is you also have a link directly to the part in the stream that I talked about it. So like, for example, this was streamed on August 4th. That's exactly the video and the part in that video that you want to go to. So it makes it very easy for you, and you also get some other hints through like topics and things if you do want. So I'll make sure to add all these questions that we worked to this list after this stream, and I'll make sure to update the description too with all the chapters and the links to the LeetCode questions. So thank you all so much for joining. I hope to see you guys again tomorrow. We'll be doing our weekly roundup, so we'll be looking at some of those older questions. We'll have some fun with that. And yeah, I hope you guys have a great start of your weekend. It's Friday. Go enjoy and